In this video, I'm going to show you how to create a set of millwork drawings and then how to coordinate the sheets that relate to millwork. So just to begin, the term millwork refers to any sort of custom wood detail, like a built-in piece of furniture or even just a custom piece of furniture. So the first thing that we're going to do is talk about how this is represented on a floor plan, and then we're going to look at a millwork sheet, and we're going to begin on that sheet by looking at the general layout and the annotations, and then we'll zoom in on some of the drawing details. So just to begin, we're going to look at this floor plan drawing, and this is actually a design plan because it includes furniture. So you can see here there is, right on this wall here is a piece of furniture that up until now we didn't necessarily know what it was, and it wasn't labeled at all. But I have created around this a line that indicates that there's a call out, and this is called a call out. When you see a plan and then you can see that there's an additional information that relates that is too much to put in the sheet. So it looks similar to an elevation tag, but it's a slightly different symbol. So the top half of the circle has a number, and that refers to the drawing number. So it's drawing number 1. And we are going to look at sheet A104 to see more information about this object. So that's the annotation there. So drawing 1, sheet A104. So that's where we're going to hop over next. So here we are on sheet A104, and you can see that there's, a series of drawings. The first one refers to, again, the tag that we saw on the design plan. So we can see drawing drawing number 1 on A104 is the floor plan, which it's rotated slightly. It's actually rotated 90 degrees from what we see on the original design plan. But let's start first by zooming out a little bit and looking at the sheet layout and some of the annotations, and then we'll zoom in on the drawings themselves. So the first thing that you'll notice here is that we have the same title bar like we've seen on preceding drawings, and in this one it's A104, and what's shown on here is millwork. You can see that on the right hand side. You can see that the drawing numbers are put in sequential order, so from 1 through 5. You can see also that the drawing labels are drawn in the same ways we saw in preceding videos, but you can see here, just as a review, the number should be aligned with the left edge of the drawing, and the line itself should extend to the right edge of the drawing. You can see here we've got the drawing name and the scale. And you can see here that we're within reason, or to the best of our ability, we're maintaining the same margins throughout. What's kind of making this sheet a little bit, breaking it a little bit from the drawing conventions of really good alignment and perfectly consistent margins, is that we have this kind of this axonometric drawing that's got then a series of notes next to it, and so it's kind of throwing off the layout, but it's intentional and there wasn't a whole lot we could do about it. So just realize that to the best of our ability, we do want to keep all the drawings themselves aligned. But you can see here a couple of other things that I'd like to call out for you. The designer, in this case myself, I had to think very carefully about what I was going to show on each drawing so that information was not duplicated across the sheet set or across this sheet, because there's a lot of information on this sheet. And so I had to be sure that I didn't repeat dimension lines across drawings or repeat notes across drawings, because there's 2 reasons for that. The first is we want to really aim for clarity here and not crowd up a drawing with redundant information. That's the first reason that we minimize it. The second reason is because if something were to change on this drawing set, we don't want to have to guess or hope or search through an entire set to make sure that we've caught the changes in all the places that we see it. Ideally, we want to show the information in one place, one time, so that if it changes, we know if we change it in one spot, we got it everywhere. So that's why information was chosen and shown on specific drawings. Much beyond that, you can see that there's a consistent, hierarchy as far as the line work goes, and then with placement of annotations and dimension lines. So now that we have an understanding of why this sheet is laid out the way that it is, now I want to zoom in on the individual drawings. So the first one in the upper left-hand corner we can see is the floor plan. And this again references the plan that we saw, the design plan when we saw this original piece of furniture. But notice it was the piece of furniture was running vertically on the design plan, but I've rotated it horizontally so that the other drawings are easier to cross-reference it to, and the sheet layout is a little bit better. On this floor plan, you can see I've got two dimension strings. So I've got an overall dimension for the width and an overall dimension for the length. And you can see that I placed the first dimension line to make room for a section tag. And that's what you're seeing right here. We have a section tag here and an elevation tag here. So the first is a section tag, and this shows what would happen if I sliced right down the center of this piece of furniture, dropped a blade right down the center, and then looked in the direction of the arrow. And so it's kind of like an elevation, except that you're slicing through structure, and that's what makes it a section. So again, dropping a blade right down this part here and looking to the right. So we can see that if we want to know what happens if we slice through this thing and how it's built, then we have to look at drawing number 5 on sheet A104, and I'll be darned, it's right there. But we'll get back to that in a second. The second thing that you see here is an elevation tag, and we've seen exterior elevations before, but we can also show interior or object elevations, and that's what you're seeing here. So if we want to look at what the front elevation of this piece looks like, we have to look at drawing number 3 on sheet A104, and look, you can see it's right down there, drawing number 3 on A104, and we can see how this looks from the front. So the plan view is very simple. It's intended to just show the footprint and what you would see if you were a bird looking down at this thing. Notice there's not textures, there's not a whole bunch of visual clutter. It's supposed to be very straightforward, and that's how it would look if you look down on it. But you can't really get a full picture of what this thing looks like, so the next thing we have is an axonometric, and this is not to scale. It's close to scale, but not exactly. It didn't reproduce very well. So I have just put right there, not to scale, so that there's absolutely no confusion. So you all have made an axonometric before, and so all I did was transfer the information and then using line work, and then made sure that I did it at a 30-degree angle, what you're seeing here. So just like how we've seen before and what we saw on the floor plan, you can see that there's a profile line which is thicker, outlining the outer edge of the drawing itself, and then a series of change of plane lines. Now, when you're tracing this, I would recommend, instead of going from profile line down or thinner, I would probably start with the thinnest line weight and then move up, because as you get here to these edges and the hardware here and these itty bitty little circles and even these lines here, a 30.3 millimeter drafting pen, it's going to smudge. So when I did this, I moved down. I used actually the textural thickness, so the 0.25 millimeter was where I started, and then for the very, very, very thin lines and the tiny little objects. And then where I could move up a little bit to differentiate and to give a sense of hierarchy and to do the change of plane that were a little bit thicker, that's where I used the 0.3 millimeter. So even though there's a change of plane on the door and there's a change of plane on these hardware pieces, and there's a change of plane for these faces here, it just won't work with a 0.3. So you've got to go down even a little bit thinner. Okay, so now that we understand a little bit of the line work here, I would like now to pull apart some of these dimension lines. So the most important thing with dimension lines is clarity and reduction of any type of visual clutter. So you can see here that I'm trying to get the notes as close to the object as possible so that I don't have extra space being taken up by this extra line work here. Also, these are placed very carefully to make sure that there's no overlapping. Because anytime you overlap or crisscross, it just compromises the clarity. So you might think to yourself, well, you know, compositionally, it might have looked better to have these notation blocks scooting down to fill up this space down here below. But if I did that, then I would have to, instead of having single line leaders, that's what this is called, I would have to have an elbow in my leader. So it would go straight here and then it would come down and bend over across here. And so I was trying to eliminate all of that. So what you can see here with these leaders, and so this again, it's an arrow, it's got an arrow at the end, but anytime we see information pulled out from an object, we use what they call a leader line. So you can see very consistent ending point, consistent line work on the edges of the arrows, and then it's touching right exactly on the object. It's not overlapping, it's not, you know, crisscrossing anything. It's going right up to the object. And then here it's just very straightforward information, no textures, and it's just describing what you would see. There's going to be some repetition of terms, so you can see here there's some laminate, you know, veneer that's repeated a couple of times, but that's really just to indicate the different finishes of all the surfaces you see. You might be wondering, well, couldn't I keep the text here and just create a couple of different leaders pointing to where the material is the same? Well, yes, you could, except that if I want this to be laminate and I want this to be laminate, then even though I could keep the text here, my leader lines would be crisscrossing other leader lines. So again, it's very intentional where these things are drawn and what things are written and where things are placed. And it's so that there's no overlap and it's clarity is of the utmost importance. So you can see here the axonometric tells a lot of information about just the sort of general three-dimensional form and the materials that are used. So if we go now to drawing number 3, this is the elevation, and here you can see that if we start first with the dimension lines, you can see I do not have overall dimensions indicating the width because that's on the drawing above. So you can see here I'm giving just a little bit more information about the dimension size and the breakdown because more detailed information is coming across in that side elevation. But what you can see here is just very simple indications. Again, major profile line in my thickest line weight, change of plane lines where I could get away with it, and it's a little bit more forgiving here because there's less angle, so I was able to use my 0.3 most of the time. I did go to a little bit smaller down here to the 0.25 millimeter to draw these really small handles and the locking mechanism here. But again, it's just very straightforward, minimal amount of information here. As we move across to the side elevation, there's a little bit of overlap of dimensions here, and there's just no way around it. The only thing that we could have done would be maybe pulled out a smaller detail here, but for the sake of time and the complexity of the project, it didn't really warrant it. But what I want you to see here is a little bit more information breaking down the dimension lines. But notice here on the dimensions, there are parts of the dimensions where I could fit my dimension perfectly, and it floats just above in my consistent text size, and it works great. But there's other places where it just won't fit. So you can see here pulled out, it's kind of a leader, but it's an arc-shaped leader. And I pulled that dimension out just to the right or left, depending on where it fits best, and wrote it as clear and neatly as possible, because again, I'm trying to avoid the overlap with the tick marks in the information. You can see here, it's the same, I had the same issue, right? So there was a very small dimension here, just 1 inch, and then 3 inches, neither of those fit. So they had to pull out and are stacked on top of each other. So that's how it's handled. Sometimes there's just no way around it, but you have to be really careful. Use your thinnest line weight here to create your dimension lines and your dimension numbers, and just do the best you can. You can see here with this side elevation, same deal. We've got the exterior profile line that's nice and thick. Our thickest line weight, change of plane line weight is medium. And then you can see here where I had to kind of get into this area here, I ended up having to use the thinnest line weight to create the knobs and the locking mechanism. And then I was able to go over it. Once I felt like I had some more control, I was able to go over it with the thicker line to create the profile. But it might take you a couple of tries to get this right, and that's okay. I've even seen students do one drawing at a time, sort of on a separate sheet of paper, and then do an underlay and trace onto the final sheet. So prepare yourself for these really detailed things. You might mess up and it might take you a few tries to get it right. But again, moving on here to the section, this is another example where I started with the thinnest line weight so that I could get the detail that I wanted. And then I was able to say, all right, I think I can go the next level up with the profile lines, go a little bit thicker on some areas. But there are times with larger objects that I start with the profile line and go in decreasing hierarchy, decreasing line weight. And then there's other times that I start thin and then I go up. And the only way that you learn this is through experience. So here on drawing number 5, this is our section, and this is what happens if you slice through. Now this information is important because this shows how something is going to get built. Now we as interior designers do sections like this just sort of as a suggestion, and then usually the millwork carpenter or subcontractor will come in and go, well, we should probably build it this way, and that's okay too. This is really just a starting point. This is a basic cabinet design. So you can see here, you've got the wall that it's being attached to, and then you've got a series of like blocking that's filling up the airspace so that this top piece gets mounted. This solid rectangle right here is basically a scribe molding that connects the structure at the top to the structure to the wall. So you can see it happens here and here and down here, and that's because there's a little tiny gap between where these pieces are connecting into the wall that leaves that airspace for the scribe molding. So this is a wall section. Again, very, very basic here, not a lot of detail because that's not what we're focusing on. And then you can see that there's some blocking for the toe kick. You can see that there's the structure of the actual face frame of the cabinet, a dash line that indicates the trash can, because it's not really, the reason why it's dashed is because it's not there, it's not in there yet. But we do see where it is going to go. And what else do we see here? We see the plywood structure for the back and front frame. We see the slicing through the door, because we would also slice through the door here. We do not see knobs, because you can see where this slice is right here. We're slicing and we're looking this way, and the knobs are right there. So you would not see knobs. That's why you don't see them here. We see the texture indicating the countertop, and it's stippled in. You can see, anytime that plywood is cut through here, it's indicated with an angled line. And there's some that I did a little bit denser than other parts, and that's really just because it's probably a different ply. You can see here a great example of what I was referring to up here about using the same note but multiple leader lines. And so you can see that is shown very nicely here without any overlap. But again, it's really hard to get all these arrows going exactly where they need to be without any overlapping. Okay. So now, as a result of this video, you should be able to know how to create a set of millwork drawings, how to place them, how to place a symbol or an annotation on the design plan or the floor plan to show, where in the rest of the drawing set you can find more information. And then you should be able to create a sheet that's got a really nice layout, that's clear with information, that has annotations properly placed without any duplication of information or crisscrossing of lines. And you should be able to now create your own set of drawings that shows line weight variation and hierarchy and just the right amount of information and detail.